Good morning, everyone. So today you will learn how to prepare a loan repayment schedule in Python based on its components, which are the initial amount, the maturity in years, the frequency of payment, the interest and the tax rate, and finally the start date. In this video, we'll be covering only the method of straight line amortization, which means the same amount of the loan before interest and tax is consumed at each period. So for the packages, we'll need the package pandas. For the next steps, we'll be setting the template, which means the table with the columns. Next, we'll set some example data which can be changed after the process is automated. O- After that, I'll show you how to set the range date, which means the column date of the amortization table. Next, we fill other components, which are the interest, the closing balance, and the amortization amount. And finally, we'll automate the process using the def function. So for the template, we'll create the table, which created will be using pd.DataFrame, columns. The columns are the date, the opening balance, the amortization amount, the interest, tax, and the closing amount. So this is the table we'll be using for the rest of the process. So for the example of the example data, let's put the amount, which is the initial amount. Let's say 10,000. The maturity, let's say 4 years. The frequency of payment will be quarterly. The number of periods, which will be naming n periods, equal 4, which means 4 quarters in 1 year. If this was monthly, we will be putting 12. Next, the interest rate, let's say 6%. The tax rate, let's say 13%. And the start date, let's say it's the 31st of October 2024. So the variables are created for this example. We start by filling the first column, which is the dates. So to fill the dates, we'll need the function pd.DataRange. So table, the column date in table will be pd.DataRange. So the date range function has 3 arguments. There are the start date, the number of periods, and the frequency. So for the start date, this will be the variable start date. The number of periods is the number of periods 4 multiplied by the maturity. Multiplied by n periods. And finally, the frequency is the frequency Q, M, or Y. So these are the quarterly data which are put for our table. So if we want to change this to monthly data, we'll put M, and the number of period will be 12, and we'll get the monthly data. So to make the table shorter, we'll be covering only the quarterly data. Before filling the other columns, we can delete the NA amount by using fill NA. So to make all the things blank. Now we start by filling the other table component. So what we know is that the initial amount will be the first opening balance. The amortization is the initial amount divided by the number of periods. The interest is the interest rate multiplied by the opening balance of each period. The tax rate is the tax rate. The tax amount is the tax rate multiplied by the interest. And finally, the closing amount is the opening balance minus the amortization. So first, to fill the first row of the opening balance, we use table dot lock. We put 0 to specify that it's the first row, since we have a zero index programming language. The colon opening, this will be equal to amount. And you see that the opening balance have been added in the first row. Next, the column amortization is equal to the amount divided by maturity multiplied by n periods, which means the number of periods in the table. And for the quarterly data of the 10,000 amount loan, these are the single amortization amount that will reduce at each period. Next, the closing amount or the interest is equal to opening multiplied by the interest rate divided by 100. For the tax rate, the tax amount is the interest multiplied by the tax rate divided by 100, and the closing amount is equal to the opening minus the amortization. So here are all the data which are put. So for the first row, the closing balance have been filled, since we have already the opening balance and the amortization. So to fill the other rows, which means the opening balance of the next period will be the opening balance of the previous period minus the amortization. So to fill all the rows except the first one, we'll use the for loop. So let's say for e in range from 1 to maturity multiplied by n periods, the number of the rows. Table dot lock from e and until the end in the colon opening is equal to the initial amount minus the amortization multiplied by the number of periods. And we have our loan repayment schedule, which is prepared. So if you want to automate all this process, we can just change the data. Let's put, for example, 5,000 instead of 10, the maturity 5 years, the frequency monthly, which means the number of period is 12, and we keep all the previous data as they were. And we run again the the code to get the new loan schedule. So here we have so here the order of the columns to put should be in this order to avoid the NA amount at each time, which has happened earlier. So we get back to our quarterly example to make the table shorter. And finally, if you want to automate the process using the def function, so we create def loan schedule. The arguments are the amount, so the arguments will be the amount, the maturity in years, the frequency, the number of periods, the interest rate, the tax rate, and the start date. And what we'll be covering in this function will be all the codes we have been running up to now. So first, the creation of the table. Next, the range, the date range. And the other components of the loan schedule. Well, so we, for a better presentation, will round all the numbers to avoid any decimals. Apply round and fill NA. So the function is created. So let's apply the same example we had earlier. So loan schedule, the name of the function, the amount, first argument is 5,000. The years are 5. The frequency is quarterly. The number of period is obviously 4. Interest rate 6. Tax rate 13. And the start date is 31st of October. And we get the loan schedule automated. So if you want to change the amount to 10,000 and to 6 years instead of 5, we will get the new schedule for 6 years. So this is the method to use how to in order to create and automate the process of a loan schedule in Python.